All right. Today we're going to talk about graphing linear inequalities. Graphing linear inequalities. Earlier in the year, we talked about how to solve linear inequalities, but this was dealing with one variable, and we learned to solve them just as we would linear equations, right? But now we're going to talk about graphing linear inequalities, and this is dealing with two variables, an x and a y. Note, a linear inequality divides the coordinate plane into two halves by what we call a boundary line, where one half represents the solutions of the inequality. The boundary line can be dashed and is dashed for less than or greater than symbols. All right? It's dashed for less than or greater than symbols. And or the boundary line can be solid, but when it is for less than or equal to or greater than or equal to symbols. So we have some steps here for what we're going to take in order to graph. And I'm just going to get right into the example so that you can get an idea. Let's say we want to graph y is less than x. Well, first off, before we can deal with anything, let's realize that our boundary line here is y equals x. That is the boundary line. All right, so I'm just going to go ahead and plot that. Realize here that our slope is 1. And our y-intercept here is 0 because there's nothing being added to it. So we're going to start right here at our y-intercept, which is 0. And then we're going to plot other points using our slope. So if our slope is 1, then our rise over run is 1, 1. So we go up 1, right 1, up 1, right 1, up 1, right 1. Or we can go down 1, left 1 to go in the other direction as far as plotting points. All right, now we need to determine whether the line is going to be dashed or solid. Well, we just set up here that it's dashed for less than or greater than. Well, this is a less than symbol, so we're going to have a dashed line. All right, we're going to have a dashed line. All right, and then you may say, well, why is this line going to be dashed? Because our y values is less than x, right? This line is representing x. And y is less than x. Our y values we want are less than x. So that means that the solutions are not on this line, only less than. So then you have to ask yourself, well, where are the y values less than x? Is it up here or is it down here? Because remember, linear inequalities divides, this is the boundary line, and it divides the coordinate plane into two halves. This is one half, and this is one half. And we have to determine which half is going to have our y values less than x, meaning this line. All right? So, well, if we're looking on this y, these y values are positive, and it is above this line. These y values are negative, and it's below this line. Therefore, our y values is less than x. It appears to be right down here. So we can kind of do a little shading here. Any point in this section down here, as long as it's below the line, seems to fit this situation. All right, so our last step, we just really have gone through these steps. And our last step is going to be, well, let's check a point to make sure we shade it in the correct direction, right? So let's say we have this point right here, all right? And this point is, looks like it is 2, -1. All right, and I'm going to put this in a different color so this can stand out. All right, this is 2, -1. All right, 2, -1. All right, and we're going to check it. So, of course, our x value is 2. Our y value is -1. And we're going to plug it into this inequality. So -1 is less than 2. Is this a true statement? This is how we check, right? Is -1 less than 2? All right, and the answer should be yep, which means we shaded in the correct direction. Now, if we tried this and the answer was false, there was no, that's not true, then we need to erase this shading and shade in the other direction, all right, which is up here. All right, we would shade up here. All right, so that's example 1. Let's do another example. All right, so we have y is greater than or equal to 2x plus 3. All right, that greater than or equal to is telling us we're going to be dealing with a solid line. So we can just make ourselves a little note up here that we're going to be dealing with a solid line, right? Our boundary line is 2x plus 3, right? So note here that our slope is 2, our y-intercept is 3, and we're going to go ahead and graph and plot that. So we started our y-intercept, which is 3, and then we plot our slope. So we go up 2, right 1. All right, or we start at our y-intercept and go the opposite direction, down 2 and left 1. All right, and we plot our points. Again, we said this was going to be a solid line. So here we go. All right, and now we're down to the shading. We want y values that is greater than or equal to 2x plus 3. Well, this is 2x plus 3. So the y values is greater than this line. Well, it seems to be above, right up here, right? Greater than or equal to is above, not down here, right? In this direction, right? Or any of these, right? Yeah. So we need to be shading, it seems, up here. This is where the y values, anywhere up here, right? Not just up here, but anywhere. All these y values is greater than our 2x plus 3. So now let's try a point, right? It's real comfortable to use the point like 0, 0. Just because it's so easy to. But a lot of times we like to use points that we assume are in the solution set. So we can choose any point we want on this coordinate plane. But if we choose 0, 0, then we expect the answer to be false because it's not in the shaded region. And if we choose a point over here, we expect the answer to be true because it is in the shaded region. So it does not matter what point you use, just know what you're expecting to find. All right, so let's say we choose the point here. All right, and this point is -2, 1. All right, -2, 1. All right, so let's check. All right, this becomes 1 because we're substituting into this equation here, right? So that becomes 1 is greater than or equal to 2 times -2 plus 3. So that's 1 is greater than or equal to -4 plus 3, which is -1. Is this a true statement, right? The answer is yes. So that means we've shaded in the correct direction. All right, now we're going to keep going. Try to make it a little quick here. All right, the example 3 says here, graph y is greater than -2/3, that should be x, plus 1. All right. Well, first off, because we're dealing with this whole greater than deal, then we know we're going to be dealing with a dashed line. So we can go ahead and make ourselves a note here. This line is going to be dashed. All right. The next thing we need to do is to graph our boundary line, meaning our negative 2/3 x plus 1. All right, take note that our slope is negative 2 over 3, so that's our rise over run. And our y-intercept is 1. So we start right here at 1 on our y-axis. And then we're going to go down 2 and right 3. Or we can start at our y-intercept and do the opposite. Go up 2 and left 3. And then we connect these points by a dashed line since we have this greater than. All right, we have now our boundary line. All right, note that our solutions will not be on the line since it's strictly greater than. All right, greater than the y values, we want y to be greater than this line. So where are the y values, or when are the y values greater than this line? And it should be anywhere up here. All right, anywhere up here. So we're going to just do a little shading here. All right, we're going to do some shading. And then we can check a solution in this region. All right, so let's say we choose the point right here, which is 0, 2. All right, this is 0, 2. We're going to check that point and see if it's true. So when we check, we say 2 is greater than negative 2/3 times 0 plus 1. So that's 2 greater than 1. Is this a true statement? The answer is yes, so we know we have graphed correctly. Lastly, we have x is less than negative 2. Now, we realized that last week we talked about horizontal and vertical lines. And hopefully we realized that this boundary line is x equals negative 2, which is a vertical line because it goes directly through our x-axis. So we're going to go right here to where x is negative 2. All right. And we're going to draw a vertical line, but realize that because this is strictly less than, then this needs to have a dashed line. So we need to make ourselves a note here. Dashed line. So we're going to do just like that. All right, and that just means that this is our boundary line, but the solutions are not on the line. And we're going to shade to the x values that is less than negative 2. Well, these x values here, negative 1, 0, 1, 2, 3, 4, and 5, and so on and so forth, are definitely greater than negative 2. So we need to shade in this opposite direction. And believe it or not, we just did our check. All right, we just did our check. All right, so we shade this way. So all our solutions, all the x values that are less than negative 2 are going that way to the left. So we just did our check for real. But if we want to do another check just to be sure, I wouldn't choose a point up here just because you got to do a little bit more multiplying. So maybe let's choose a point that's on this line, you know, like there. And this point is negative 3, 0. So let's check there. All right, even though we already did our check. Note that our x is negative 3. Is negative 3 less than negative 2? The answer is yes. So that's how we know we shaded in the correct direction.